Hey everyone, in the previous video we discussed about the 5 scalar data types. Now one very important property we need to remember is that all scalar objects, which means objects of these 5 scalar data types, are immutable, which means once these objects are created, the object values can't be changed. This statement might be confusing to some of you because you might think that changing the value of a variable is same as changing the value of an object, but it is not. Let's try to understand this using an example. Here I am creating a variable a and I am assigning an integer value 5 to this variable. Now what happens when this is executed? Python will create an integer object with value 5 somewhere in memory, and then it will make this variable a reference to this integer object. In simple words, we can say variable a will become a reference of this integer object in memory. Now what happens when we try to change the value of this variable a? So here I'm trying to change the value of a by reassigning it with a different value 10. We can directly assign this value 10, or we can use some sort of an expression like a plus 5. As a is 5, this will evaluate to 10, right? So even in this case, 10 will be assigned to this variable a. So whatever it is, here we are trying to reassign variable a with a new value 10. When we do this reassignment, what actually happens is Python will create a new integer object with value 10 at some other memory location. And now variable a will refer to this new integer object 10. But it will not modify the value of this existing integer object 5. As you can see, this object is not changed. It's just that variable a will now refer to this new integer object 10 without impacting the previous object it was referring to. Now what happens with this previous integer object 5? There is a process called garbage collection which happens in the background. If this object is not being referred anywhere else in the program, this object will be deleted from the memory. So once these scalar objects are created, they can be deleted, but they can't be modified. In this example, I've taken integers, but the behavior will be same even if you take other scalar objects as well. And apart from these scalar objects, there are also some other objects which are immutable, like strings, tuples, etc. We will be discussing about them in future. But for now, our focus is on these 5 scalar data types. Now let's see a small demonstration to understand more about this. So here I'm creating a variable a and I'm assigning a value 5 to this. So what happens? An integer object with value 5 is created somewhere in memory. Let's assume it is created at memory address 140.148.150. This is just a random memory address I've taken for example, alright? Now in the next line, I'm assigning this variable a to another variable b. This is called copying reference. What do we mean by this? We know that variable is a reference of an object, right? So when we assign a variable to another variable b, we are basically copying reference, which means that b will also refer to the same object a is referring to. So variables a and b, they end up referring to the same integer object 5. And how can we confirm that both of them are referring to the same object? We can use a function called id. id of a variable will give us the address of the object the variable is referring to. Now if you try to print id of a and id of b, we will be getting the same memory address, which means both these variables are referring to the same object. Now let's see this example in action. So I've created a Python file immutability.py. And here I've added this example. So I'm creating a variable a, assigning value 5 to this, and here I'm copying reference, which means I'm assigning variable a to another variable b. And here I'm trying to print variables a and b, and in the next line I'm also trying to print id of a and id of b. Now let's run this program and see what happens. And as you can see here, both a and b have same value 5. And more importantly, both of them are referring to the same object. We can see the same address printed here. So this confirms that when you copy reference, both variables end up referring to the same object. Alright. Now at this point, both variables a and b are referring to the same integer object 5. Now what happens if we try to change the value of a to another value, let's say 10? This integer object 5 is immutable, so this value can't be modified. So what actually happens is Python will create a new integer object 10 at some other memory address, and variable a now refers to this new integer object 10 without impacting the previous integer object 5. Now if you try to print a and b, it will print 10 and 5 because a is now referring to this new integer object 10, but b is referring to the same integer object 5. This object is not modified, so it will print 5. Value of variable is nothing but value of the object the variable is referring to, right? So here we can say value of b is 5, value of a is 10. That's why when you try to print a comma b, it will print 10 comma 5. And now if you try to print id of a and id of b, so id of a will give you a new address because a is now referring to a new integer object 10, but b is still referring to the previous integer object 5, right? So we get the same address here. If you see before this, a and b are referring to this integer object 5 at this memory address 140.148.150. Now when you change the value of a to 10, a will now refer to this new integer object 10 at some other memory address, but b is still referring to the same object, right? So that's why id of b will still give you the same memory address. Now here in the next line, let me change the value of a to 10 and let's print a and b and id of a and id of b. Now let's see what happens. If you run this program, so as you can see, initially both a and b are referring to the same integer object 5. So that's why the value is 5 and the address is also same because they are referring to the same object. Now when you change the value of a to 10, a will now refer to a new integer object 10, but the previous integer object 5 is not impacted. So now when you try to print a and b, it prints 10 and b is still referring to the same integer object 5. So it will print 5. And you can observe that id of a will print a new address because a is now referring to a new object. But id of b will still give you the same address because b is still referring to the same object. We can see the same address is printed for id of b. And one thing you have to notice is when you rerun the program, you might get a different set of addresses. You might not get the same addresses because these objects were created during the execution of the program, right? During the execution of program, these objects were created and we were trying to print the addresses of these objects. Now once the execution is over, these objects will get deleted from memory. And when you rerun the program, let's rerun. So these objects will get created again, right? So you can see new set of addresses, right? But the important point is both a and b will refer to the same object initially because we are copying reference, and even after reassigning variable a, we can see that variable b will refer to the same object. So in this demonstration, we observed that even if both variables a and b are referring to the same immutable object, which is integer 5, they are not impacting each other. We have seen that changing the value of variable a did not impact b because integers are immutable, and when you change the value of variable, it simply refers to the new object. It will not modify the existing object. So even if 10 different variables refer to the same immutable object, they don't impact each other because none of them can modify the immutable object. If any variable wants, it can go and refer to the new object, but none of them can change the value of the existing object. But the game completely changes when multiple variables refer to a same mutable object like list or dictionary. We will be discussing about them in future tutorials. But when it comes to immutable objects, even if multiple variables refer to the same immutable object, they don't impact each other. Now Python does something interesting by taking advantage of this immutable property. In this example, we are basically copying reference to another variable. So both the variables a and b will refer to the same integer object. But instead of b is equal to a, what if we have b is equal to 5? Now here we are not copying any reference. So what do we generally expect? A will refer to some integer object 5 and B will refer to some other integer object 5. That's what we expect. But what Python does is it will make variables A and B refer to the same integer object 5. If we assign this integer value 5 to 10 different variables, instead of creating 10 different objects, it will create only one integer object with value 5 and it will reuse the same object, which means all the variables will refer to the same integer object 5. And why does Python do that? Because we know that integers are immutable, and even if 10 different variables refer to the same immutable object, they don't impact each other. So Python tries to reuse the immutable objects for efficient memory management. And we can observe this reusability not just with scalar data types, but also with some other immutable objects like strings and tuples, etc. Now the question arises, will Python reuse immutable objects all the time? It is not guaranteed. Actually, there are some rules based on which Python reuses the immutable objects, but we don't have to worry about it because it is something Python does behind the scenes for efficient memory management. And these memory optimizations might change with new versions of Python, so we don't have to worry about it. For us as a programmer, it will not impact the logic of our program even if immutable objects are reused or even if it is not. Because we have seen that even if multiple variables refer to the same immutable object, they don't impact each other. So it doesn't impact the logic of the program. But when you copy the reference, for example, by doing B is equal to A, so here as a programmer, you are specifying that B should refer to the same object because you are copying reference. So A and B will definitely refer to the same object. And here you have to be aware of consequences completely. But in this example, as integer objects are immutable, still A and B are not impacting each other. But we will see the problems of copying reference when we discuss about mutable objects like lists. We are going to discuss this concept of mutability versus immutability many times in the course. That will make these concepts much clearer. But I hope with this video you got a basic idea of what immutability means. So the important point we need to remember from this tutorial is all scalar objects are immutable, which means once these objects are created, the values can't be changed. The second one is even if multiple variables refer to the same immutable object, they don't impact each other. And so Python may try to reuse the immutable objects for efficient memory management. That's all for this tutorial and I'll see you in the next one.